All right, everybody. So I wanted to talk about quadratic inequalities. I'm going to walk through the two different types of problems we see. The first part of this video will deal with graphing quadratic inequalities, and the second part will be solving these inequalities algebraically. So when I approach graphing quadratic inequalities, I'm going to approach this very similarly to how I would approach graphing a simple quadratic function. So I'm going to start by finding the vertex. It's going to be negative b over 2a, in this case 2 over negative 2. That puts negative 1 at the middle of my function. So I'll also plot the points negative 3, negative 2, 0, and 1. Just as I would in a normal quadratic, I'm going to plot each of these points. I know if I plug in 0 here, I'm going to get 3. And using symmetry, I'll also have a 3 when x equals negative 2. When I plug in negative 1, I get negative 1 plus 2, which is positive 1, and plus 3, which is 4. When I plug in positive 1, I get negative 1 minus 2, which is negative 3, plus 3, which is 0. Using symmetry, I fill in the rest of my table. So up until this point, graphing a quadratic inequality has been identical to graphing a quadratic equation. I'm still going to plot those same 5 points, and I'm going to go ahead and do that now. I'm going to start with my vertex. I'm going to plot the point negative 1, 4. There it is. There. 0, 3. And its symmetrical pair at negative 2, 3. And finally 1, 0. And negative 3, 0. Now I have to ask myself, what type of line will I use when I graph this quadratic inequality? Well, because I have a greater than symbol, I'm going to use a dotted line when I graph this quadratic. Remember, dotted lines, we can think about them as open circles. Basically, it means that the line itself is not included in the solution set. The last part I need to figure out here is, where do I shade? Now, there's two ways we can go about this. The one that I talked about in class the first time around is trust your instinct. If we have a greater than symbol and we go to the vertex, greater than, I'm hoping you're thinking, is above. So the region containing the area above the vertex should be shaded, right? So I would shade everything, outside of the vertex. What did I do? I said, well, I went to my vertex and I have a greater than symbol. So I go from the vertex and shade upward. That tells me where to shade. The other way I can do this is to test a point. If I were to plug in the point 0, 0, I can see on my graph that it is inside my parabola. If I test it algebraically, I get this statement here. 0 is greater than 3. Well, I know that 0 is not greater than 3, which means this point, 0, 0, should not be included in the shaded region. Instead, I shade everywhere else. So I graph the quadratic parabola as I would if it were an equation, and then I decide, do I use a solid or dashed line? And then I have to decide where to shade. Let's move on to part 2. Solving a quadratic inequality algebraically. Just like we saw on the graph, we want to approach this as if we were solving an equation. So we're going to turn this into an equation and set it equal to 0. So I'm going to subtract 2 from both sides. So I have an equation that's set equal to 0. And I could solve this any way I like, but this particular problem is factorable. So I'm looking for a pair of numbers that multiply to 8 and add to negative 6. And what I find is that my two factors should be x minus 2 and x minus 4. Which means that this function here crosses the x-axis at 2 points, at 2 and 4. Really, we're trying to find where that function is greater than or equal to 0. So I have figured out where this function equals 0. I know it equals 0 at 2 and at 4. And similarly, similar to what we just did over on our graph, I need to figure out where to shade, okay? If I'm trying to figure out where this graph is greater than 0, well, I need to figure out where 0 is. So I'm going to plot 0 as well on my number line, and then I'm going to plug 0 in to my original problem. When I plug in 0 for x here, x 0 squared is 0, negative 6 times 0 is 0. So I'm left with this statement here. 10 is greater than or equal to 2. That's true. So I'm going to shade in the direction of 0. And what else I know is that quadratics always have solutions that converge or diverge. In other words, they always either point directly towards each other or they point away from each other. Because the solution to the left pointed left, the solution to the right must point right. So this is a situation where our solutions diverge. So our full solution here is that x is less than or equal to 2, or x is greater than or equal to 4. So this is really my solution here. I have diverging solutions. X is less than or equal to 2 and greater than or equal to 4. Just one last part, maybe this makes sense. If we're comfortable with our graphing, we know that this function is this function would open upwards on the graph. So in a sense, this graph looks something like this, right? It's our quadratic parabola. So it makes sense that the place where this graph is above 0 occur outward, right? Outside of 2 and outside of 4, our graph is above the x-intercept. And we are done.